Hi everyone, my name is Rob Canzaneri, and I'd like to welcome everyone to the Data Architecture Virtual Chapter for PASS. Today I asked Bryan to come on and talk about integrating R with SQL Server, and he was really nice, and he accepted it, and we're going to have a great webinar today. I talked to him a few minutes ago, and he told me about the topic, and it sounds really great, so I hope everyone enjoys it. Just to get a few logistics out the way, the session is recorded, and we'll put it on the YouTube site, and the link from our data architecture chapter, I'll put a link from there to the YouTube site, and if you email me, I'll be glad to send you a link. Okay. So I'd like to thank Nutanix. They sponsor this chapter, and occasionally we give away money and different prizes, and they support us. And thank you, Nutanix, for giving us your support to make the data architecture chapter for PASS possible. It's a big deal to have it and have great speakers every month. Upcoming meetings, I'll send an email out too. We're going to have Kimberly on and talk about database designs. Tim is going to talk about tuning SQL Server, and Glenn just agreed to get more into the deeper hardware of integrating our hardware with SQL Server, architecting it in. So thank you, Glenn and Tim and Kimberly, for all agreeing to come on our virtual chapter. PASS gave me this slide, and they're redesigning some the site, and they're basically asking y'all to go log in and check it out, the new logos and brands. So if you have some time, log on to SQL PASS and check it out. They also have a store, and if you're interested in buying like mugs or different items, you can log in here. There's the link, and you can check it out. A lot of virtual chapters out there, and I highly encourage everyone to kind of check out the different chapters, and if you subscribe, you'll get links to the meetings, and it's really cool to see different topics and different areas of interest. And the link is sqlpass.org/VC for virtual chapters. Upcoming SQL Saturdays. So if you're in Boston or different areas, Cleveland, you can sign up at SQLSaturday.com, and I highly encourage it. They always have a lot of great speakers, and they come out and they give their time and teach for free on a Saturday. You can't beat it. So with that, I'd like to thank you, Bryan, for coming on today.
Thank you. It's good to be here.
And I'm going to pass it over to you right now. Make you the presenter. And I can see your screen, and I'm going to kind of mute myself out during the presentation. If you need me, shout. Thank you.
Sure. All right. Thank you. Thank you, everyone, for coming. I'm going to start the presentation, and you'll notice I'm in our studio, and this kind of part of the sort of side benefit of the presentation is demonstrating doing presentations completely from within the R IDE R Studio using something called R Markdown. And I do that because that's kind of the only way people who do R programming ever do presentations. I've never seen anyone bring up separate PowerPoints. So I'm going to jump right into it, and it comes up with HTML slides, they call them. And it's kind of cool. So you can see little navigators. I can navigate around like any other PowerPoint, but it's actually generated and maintained within our studio. And the nice thing is if I have code examples and things, automatically they'll update the output when you generate the slideshow. So it's a way to keep things together. So the title of this is SQL Server R Integration, and I like to call it the ultimate analytics platform because I love SQL Server, and I think putting R together the way this does is awesome. And a little about myself. So contact information on the left. Feel free to join me on LinkedIn. I also do a fair amount of tweeting, usually technical tweets. I don't get into current events or anything. I just like to talk about technical things. And I'm author of Pro PowerShell for Database Developers. I'm a Microsoft 2016 MVP. I found and lead the past chapter Microsoft Rhode Island Business Intelligence User Group. Also have a R user group, which is Southern New England R user group, which there are very few of those, so that's why I started it. I've had experience in healthcare, insurance, e-commerce, utilities, all the good stuff, and I speak at quite a few events and decades of IT experience. So a little about what we're trying to accomplish today. One is to find out, well, what do we mean by SQL Server R integration? Two, why is it needed? Finally, how does it work? And that last bullet, that how does it work, is going to be explained by kind of walking through the code, because I really like to look at code to see how things fit together. Until you show me something in PowerShell or something, I don't really know what you're talking about. So that'll do, hopefully, that piece. What I don't have the time to cover, though, is an introduction to the R language. So I do presentations like that. Maybe someday I'll come back and do that, but that won't be done here. So bear with me. If you're not familiar with R, hopefully you can still get enough out of this. A lot of it's architectural and kind of overall architecture type discussion. So why R server? Well, the answer comes down to limitations of R. First of all, R itself, the language, is a client-side only tool. It's not server-based like SQL Server or something. It just runs on your machine. Not much different than Excel. The data, like Excel, I guess, would be limited by your client's memory. So if you're running on a machine with 2 gig, you're not going to be able to load very much. It runs single-threaded. Any database data you want to use has to be extracted from the database and used. And if you want to write it back, then you have to write SQL statements to write the data back to the database. It's relatively slow, and there's no scheduling tool. So the solution came up by a company called Revolution Analytics, and it's called R Server. Now this is a proprietary solution that provides scalability for R. It has multi-threading. It supports a shared R server, much like SQL Server. You know, you think of, I've got some R code I want to run, I submit it to the server. It runs on a very scalable, high-end server that can do multi-threading and all kinds of good stuff and sends the results back. So very much like SQL Server, if you want to think of it that way. They implement performant versions of common R functions. So they kind of say, don't use the common R function to do a logistic model. Use a function called RXGet to do it. And by doing that, they're giving you one compiled, efficient code, but they also designed for multi-threading and all kinds of other stuff. And you've broken now the barrier of being limited by the client memory. Even the server memory is not a limitation. It will page in and page out memory as needed. Which is why SQL Server came along. Microsoft said, we need an analytics platform. And I think that was a brilliant move. They saw Revolution Analytics, and they saw what they do, and they thought, let's integrate that with SQL Server. So they bought Revolution Analytics about 2 years ago, and they integrated their server product into SQL Server. So SQL Server 2016 is the first release of SQL Server that integrates this Revolution Analytics server. And one of the first things you see when you look at this is that you can now write stored procedures in R. So you can write stored procedures that are either R or T-SQL, and I guess you can also do CLR. So it's kind of extending that idea of being able to do other languages within a stored procedure. And a nice benefit is SQL Server and R share a memory space. So instead of exporting data in and out, you can do things right within SQL Server. You could have a view or stored procedure which returns data, and it doesn't have to export that data to R to be used. It can be used right in its place. And the nice thing about that is that now you can really optimize what SQL Server does well, you let SQL Server do, and what R does well, you let R do. And that's kind of getting the best of both worlds. So kind of the value proposition from Microsoft here is basically flexibility and agility. So a big word you're going to hear in this is called operationalize. And the idea is you've got something that was developed by a data scientist. They're not programmers. They write code. They're really trying to prove out some relationship, some predictive model. Maybe they're just trying to find out what the cause of a cancer is in certain patients by looking at different metrics about the patient. So they're not programmers. As a result, they may create a very limited use, limited scope solution. And the idea here is now with our server, you can export that and you can create an operationalized solution which scales well, which can run through a stored procedure, which can run from SQL agent, which can be called from outside the database by something like SSRS or whatever you want. So they give you a lot of options that weren't there before with R. And again, all the scale issues are addressed. You don't have to worry about running out of memory. You don't have to worry about parallelizing. It's all done. And if you already own SQL Server, then SQL Server Enterprise, then you already own the R server that goes with it. So it's a freebie basically thrown in. And kind of stepping back a minute and getting around this operationalizing idea, which is kind of I think it's more of a Microsoft idea. It's been merging, but it's a good one, I think. And I'm seeing it right now on a client I'm working at. which is you have data scientists, and they're not programmers. They learn how to use R. They're extremely intelligent people. A lot of these guys have, or girls have, PhDs in statistics, but they don't do programming, so they do programming badly sometimes, and they're not thinking efficiently or anything. And a lot of times it's very iterative. They may go back and forth for months trying to find something that finally works, and half the time I'm seeing an example, real world examples where they're massaging data manually, they're editing data and stuff and fixing it to get it to work. So obviously that's not scalable. It's not something you want to put into a production application. So then you see below the data scientist is a data developer, could be a DBA, could be a database developer. And the idea there is they take what the data scientist did, but now they may take pieces of it and write it in T-SQL, and they'll take other pieces and keep it in R, but maybe they'll switch it to the scalable RX functions. And finally, they'll put it in the database and maybe set up some SQL agent jobs that will run refreshes on the predictive models, maybe run some data sets coming through, new clients applying for loans. It could apply a predictive model to say whether or not they're likely to pay the debt, that kind of thing. So the operationalizing idea is really kind of like basically data science for the enterprise or for the rest of us. So when you talk about, again, operationalizing, again, Microsoft bought Revolution Analytics, and they used to have a product called Revolution ROpen. So the only difference now is it's called Microsoft ROpen. That's a free client-based, basically R implementation of the R language, and it's nothing more than a CRAN distribution. So CRAN is the owners of maintaining R in the open source world, and Microsoft ROpen is really just sort of a locked-down version that they took a snapshot of one release that's stable, that they feel they can support, and that's called ROpen. If you want to use Microsoft Scalability or R servers, you must use the ROpen, because sometimes the later releases introduce bugs that, really Microsoft can't be answering for. They don't want to answer for bugs that just got introduced in 2 days ago's release. So that's the idea of ROpen. And on the other side, you have the commercial products. They call Revolution R Enterprise, and we see what we're talking about today on the left, SQL Server R Services, which is just a R server implementation that's contained within SQL Server, and then you have the standard R server, which is sort of standalone, and you could just have it sitting on a server and anything could submit R requests to it, and it has some interfaces to Teradata and things like that. So it's kind of a nice licensing feature that Microsoft now has. They can make money off of Teradata by letting them use and charge for this licensing. And I've got some links in this, which I'll publish later, these slides. These links you can use to go anywhere. And by the way, this presentation, if you do get the slides to go with it, just go to the HTML extension. It'll be R SQL Server integration.html, and if you have RStudio, you can just bring in the script and run it, and it will generate the HTML. So either way. Okay, so again, Microsoft R Server is enterprise scale analytics, and what they do is they implement a bunch of special functions that are called scale R functions, and that's one part of it. The other part is they have parallelized computations. So when you're doing predictive models, especially with large amounts of data, a lot of times could be 150 different variables that you're trying to use to predict an outcome, and that's very resource intensive. So by doing parallelized computation, you can speed it up a lot and make it a lot more efficient. There's no memory limits, and remote execution is really handy because you can submit your request to the SQL Server, your R request, and it will do it right there, and it can move between SQL Server and R very seamlessly. There's something also called Deploy R, which if you've ever seen in Azure, we'll see it later a little bit, an Azure ML demonstration, at the end they say, now let's publish a web service to wrap around our predictive analytics, and that's really Deploy R, and that's exactly how they do it in that demo. So Azure ML does use R and all these tools. So ROpen, again, ROpen is an open source R distribution that is fixed stable release. CRAN is always adding updates, so they don't want to be bothered with that. There is some enhanced performance math functions which are proprietary and given as part of the ROpen, so you will get some performance benefits from that. And again, it's used in place of the standard CRAN download, the latest, greatest CRAN download. And you have to use it. So if you're going to use R server integration with SQL Server, you need to use that particular version of R, whether it's on your client or on the server. The server, when you install the server piece, it will automatically install ROpen on the server. Okay, so the Microsoft R client is really just a fancy word for a bunch of libraries that you use with the R language, and we'll look at these RX functions, and that's basically what it is to allow connecting to our server, but also for scalability locally. So a set of R packages and implements R scale functions, but if you're learning locally, they're limited in their scalability. It's a good way to learn, for learning and development, especially if you're going to be doing SQL Server work. And it can be a good option if you're having some performance issues like calculating a model in a reasonable time. It's a possibility that by just going to this version, you could get higher performance and it might meet your needs. Now the R server, which is our real focus here, this is a standalone R execution environment. The clients submit requests to our server for processing. It can be contained within other environments, as I mentioned, and there are versions for Linux, Hadoop, and Teradata. And the SQL Server has very tight integration with it. So ScaleR is proprietary high-performance functions that are replacements for standard R functions. They start with a prefix of RX. We'll see a lot like RX import. Can be used with Microsoft R Client, which is free, but again, limited scalability. And sorry, there was also a link there that you can follow for more information. So there's a whole PDF out there that will talk about all these different RX functions, what they do. Deploy R is known as the integration server. It's an optional framework for deploying R so that desktops, mobile applications, anyone basically creates web services around them and provides analysis services such as a predictive model, so that kind of thing. So you can actually expose your predictive model as a web service. So there's some things, there's a great thing, somewhere I have a link in here, but if you Google Microsoft's data science walkthrough, I'm basing what I'm doing here on that, and I've called out pieces. I had to make a few fixes in places. What they originally did 6 months ago doesn't work now, and I had to adjust some things, and even some pieces within that I don't think work either, which I'll talk about. But it's a good starting point to kind of get a sense of the overall architecture for this. So there's instructions there. And one thing I found is when you install the R open language, if you've already got, as I did, R installed with a ton of packages I downloaded, it's like starting with a white slate. You're starting clean, and you have to download a lot of packages. So what you can do is just go down to where R installs your packages and unzip them over in a quick way and just grab the packages you want and put them in the lower path there, which is where, by default, the R server puts its copy of R. So you can also just download them from within that particular R GUI or whatever, the R language from there. The other thing to mention is, as you know, SQL Server is a bunch of services running. So the database has a database service, and SQL Server integration is a service, as well as reporting services. Well, with R, there's a new service which is called LaunchPad. So I kind of think of Mighty Ducks and the LaunchPad guy that's always flying around the plane and crashing. So LaunchPad is a new service. It's a little weird to me because it's the one that doesn't really tell you what it does by its name. But if that's not running, you're going to have problems. So you do have to make sure that LaunchPad, if you have any trouble, if it's saying it can't start the service or it can't connect, take a look in your services and make sure that LaunchPad is running. Also make sure that your database is running, because obviously if you don't have a database running, you're not going to be able to get to the LaunchPad. And by the way, if you stop the database, it will automatically stop LaunchPad, so make sure you kind of keep those in sync. Finally, something I didn't discover until a little bit too late for me, but you can save yourself some trouble. If you do use RStudio or RTools for Visual Studio, either one, they're both good platforms, you can change where that ID is looking for the language. So if you change it to point to where the R server R client is, then you're getting the R open compliant version, which makes it easier. It enables you to do work with R server integration. Otherwise, you're really not pointing at the right version, and you won't be able to do that. And you can change it back, so you can have multiple versions of R on the same client. All right, so let me tab out of here for a minute, and now I'm going to go in and start taking a look at what all this looks like. Okay, so I've got a lot of comments in these slides. Again, I'll zip it up later, but the first thing I want to do is kind of walk through a very simple script that's not actually making use much of the R integration yet, but it's going to start looking at using the RX functions, which is a key part of making use of the R integration in SQL Server. So we're using R open at this point. I am in RStudio, and again, you can use RTools for Visual Studio. That's fine too. I'm about to publish a blog comparing the two. For what it's worth, I think they're both great platforms. I think RStudio is a little bit better for data science, but I think Visual Studio is really coming along as being the tool of choice for that kind of operationalizing things. So kind of some comments here. So this is from Microsoft's own kind of walkthrough, but they start with what they call low scale, which is just trying to get an example of things. So one of the things you get here is you can store like basically environment variables as part of this using a function called RX. And this is really set up by default. You have this ability, and when you set up the walkthrough, it sets up a sample directory as a way of pointing to things. So basically what this is going to do is just store in the variable in data file. It's going to store the path to my data file that I want to load. That's all it's doing. Okay, and if I take a look at it, you can see that's all it's got, just a long path. And now what I'm going to do is I'm going to run this RX import, and notice it has a parameter in data, and in data file is up here. So it's pointing to that path to a CSV file. Now typically read CSV, read.csv in R is what you'd use to load a data file that's a CSV. But in this case I'm going to use the R supplied, the SQL Server supplied version, RX import. So this is part of Revolution Analytics R client. And you can notice things down here. It's doing something you don't typically see in the R world. The biggest thing is notice the chunk time. So had this been really large, it might have done multiple chunks, which is just basically batching. So it might have loaded like a 500,000 rows, then chunk next 500,000 rows, and it can store the data in chunks, things like that, and process it. So it is a scalability feature it does. Unfortunately, on the client itself alone, if you didn't install the other things, if you were just trying to use this without SQL Server, you won't get all the benefits. And if I do this str is a built-in R function, which is kind of like describing a table. And what I've loaded here using RX import is what's called the data frame in R. And you can see it's saying I've got 10,000 observational rows, 6 variables, and it kind of gives me a description with some data samples of what's in there. So that's this out-of-the-box str function. The dim function just gives me how many rows and columns. And if I use RXGetInfo, that will give me, that's a different version. That's the Microsoft supplied scalable one, and that is not critical to use in this particular case, but you're really going to have to start using the RXGetInfo once you're starting to run on the server side of things, and we'll look at that in a minute. But it's kind of a nice function too because it gives you more information. It kind of combines describing it with giving you like the head function will just give you a few rows so you can see it. So it's kind of a nice function, and the head function will just give you a few rows so you get the idea of that. Okay, so now we're going to start scaling it up a bit, and what I want to talk about is this thing called an XDF file. So Revolution Analytics came up with this idea of we grab data, and when we want to hold it temporarily, we're going to store it into a format of compressed, really fast loading format called XDF. So if you ever use SSIS and you know that it has a raw format and that's optimized for SSIS, and different tools do, XDF is specially formatted to work with Revolution Analytics functions for very quick manipulation and loading. Okay, and we're going to take a look at some of that here. So again, I'm going to now get a new path, but a different file which is bigger than I had before. Let me just get that without. And what I'm doing, by the way, hopefully I'm not confusing anyone, I'm highlighting a few lines and then I'm clicking the run. If you use PowerShell or other things, that's just a way to, you select a few lines and run it at a time because I don't want to run the whole script or it'd be too much to explain at once. So I'm just kind of stepping through. Okay, and now I've got, again, it's just a pointer to a file. And now what I'm going to do, now interestingly, if I do a struct on that, it will just tell me the path to the file because it's just a string. And now I'm going to give it some out file destination names. So I'm going to run that, and that's, again, those are just variables. But what I want to do is I'm going to run the RX import this time, but I'm now telling it I want to go to out file, which is my mortgage data. Now, try not to get confused. This is a parameter name, which must be out file, and this is what I happen to call it. And later on, I call it out file too. So I use the same name for both. It's probably not a best practice, but you get the idea. So I'm going to be doing the RX import, and it should go into this variable mort data. So that's ultimately going to be an object storing my data when I'm done. And this is a little bigger, so it might take a little longer to pull the data in. Okay. And now you can see, so an interesting thing here is I can see that it took advantage of chunking because I can see chunk time once, chunk time twice, and it looks like 500,000 rows per chunk. So you can see it actually scaled up, and it also wrote out an output file. So this would be a good, one way you might use something like this is if you wanted to pull a lot of data in and make it faster to use the next time, you could do different types of massaging, etc., and then write it out as an XDF file. And next time you come in, you could read the XDF directly in and stop manipulating it. Now realize we haven't really gotten into the SQL Server integration, but it's important to understand sort of that it's not completely dependent. The SQL Server integration is kind of an added bonus, but there's a lot there before you even get to that. So I'm going to, again, do the get info thing on this. And we can see if we look at this, it tells us our variables, the data types, and apparently it's a lot of data. I think it's about 10 million rows, but it explains it in exponential notation, which I've learned is never a good sign in terms of it means you got a lot of data. Okay. So now we're going to start getting into a little bit more about what's called the context, and this gets a little more into the server side. So this line here is called set compute context. Now, the context, the easiest way I think to grasp it for me at least is when you're sitting on your own machine and you're on the C drive, you know you're working on your own machine. If you copy a file, it's on your own machine's drive. But then suddenly you go to UNC like / or $ something, you go to another drive, or if you have like an X drive and that's a network drive, you know that if you go X : and you're sitting on some network server somewhere, that you're not sitting on your own machine. So in a sense, you've changed your context. Now you're running on the server. Well, in this, and if you ever use Spark, Spark actually uses the same exact idea. They call it set context, the same thing. You switch modes. So what you're doing here is you're telling R that you want to change your context to local. Now, in the first release, prior to the official release of SQL Server that I played with, by default it assumed local. But now if you don't set it to local on some functions like the data step, it gives you errors. So be careful if you stop playing around and you have problems. Try to remember what I said. You might have issues if you don't set context. And now that I've done that set context, now I'm going to run a really cool function. I'm an ETL guy, so I like this kind of thing. But this thing called RXDataStep. RXDataStep is an all-in-one ETL function. So it lets you do source, target, destination, transformations all in one function. So it's kind of cool. So we're going to, the result, and by the way, in R, if you're not familiar, this is just the same as an equal sign. Okay, so it's just assigning. So I'm going to take more data new, my object, and the output of this transformation, this ETL, is going to go into it. And let's kind of step through this a little bit. So my in data is the data we've just loaded before, the mortgage data, mort data. The out file is out file 2. So we're writing out, we're extracting the result to another file. I'm going to drop some variables. So in this case, I'm dropping year. So it's kind of handy you can do that. And that's a parameter, just part of this function. I can do a filter. So in this case, I'm saying I only want rows where credit score is less than 850. And here I'm doing a transform, runs a little of SSIS. So think of this as a create column transform or drive column. And I'm creating 2 new columns, cat debt and low score. Cat debt is going to use this function called cut. What cut really does is it's banding. It's looking at ranges and it's assigning a value based on a range. So I'm going to be looking at ranges of CC debt. And if CC debt, which is the person's debt, is between 0 and 6,500 inclusive, then it'll get labeled a low debt. And if it's greater than that, up to 13,000, it goes to high debt. And I played around. I was wondering what happens if it's above 13,000. None of the data fits that criteria, but probably you might want to just bump it really high, that kind of thing, so that you capture everything. Now, low score is looking at, it's going to evaluate if credit score is less than 625, it's going to assign a 1. Otherwise, it's a 0. So it's a Boolean. Now, the one thing I want to point out here is cat debt is what's called a factor. And factors gets into statistics. So not surprisingly, R is all about statistics. And what it does is it doesn't like text descriptions. It likes numbers. If you want to do a model on something, you might want to say, tell me if this person, based on some variables, are they low debt or high debt? It's not going to, it doesn't do that assigning strings. In fact, in statistics, you wouldn't either. You have to create bins for it, little numbers to assign for each one. And that's what factors are. But the nice thing is factors are kept track of so that it will translate the factor number to the name. So we'll say in a model, it'll say, 500 people have low debt, 600 have high debt, even though in reality behind the scenes it's a number. So it's kind of a thing, and you do have to watch out for factors in R. So let's run this through. And it takes a little bit, there's quite a bit. Okay. And so that now I'll put a data set which consists of just what we wanted, and we should. Now here's a point I do want to make because I was playing with this. So we can do the SGR function, and it doesn't look like a data frame, and there's a reason. We're getting into some pretty advanced stuff here, and what it actually did is it converted, it's really created a stub. So we created a file, and it's got to point it to that RDX file, and the class that is created is called RXDF Data. So that's a class, that's an object. And then there's all kinds of stuff. You can see it says file system, and it's pointed to this, it tells where it is, all that stuff. So it's hidden from us, we can manipulate it, but it's in there by default. So that's how that is represented. And that kind of thing is the kind of thing you'll see a lot more of when you get into more of the server side, but you can also do it on the client side. Now, this particular expression is just to point out, in a data frame this would work fine, but it doesn't like it because it's not, it's what's called an S4 class, which is a type of R class, not a data frame. But, so here I'm going to do a histogram. Now, normally I believe hist is the histogram in R, but here it's RX histogram, and I'm going to put that data through it. And we can see from this that it just plotted a histogram, and it did it pretty quickly. So I have to say that's probably a lot faster. I mean, we're talking a lot of rows of data, and it was able to plot that pretty quickly. And I'm going to talk about something else which is kind of cool. So you can aggregate data. If you want to do a lot of querying and playing around with aggregated data, you can create a sort of in-memory cube, which they call RXCube function to create it. And here we're going to say, using the credit score and cat debt, it's going to create a sort of summary, an aggregation using the two, and then we can do a plot of the two. So I'm going to run that first. And again, you can see it's chunking multiple times, so this is not a small amount of data. It's not trivial, but we're still running just as a client. And then just do a line plot. And so what I was able to do is that I was able to group by the category of debt, high debt, low debt, which we created before. And I'm also able to see the two ranges. So very useful for just analysis, even if I'm not doing predictive modeling. I can see the frequencies in this kind of thing using the line plot. So again, RX line plot will not work if you're not using the analytics client. Okay. And finally, we're going to do a quick demo. I'm going to get more into this in a different script, but I want to create a model, a predictive model. One of the most common models out there is a logistic model, a logistic, because it uses a logarithm function, and it's called, in R it would just be called Logit, but the special RX version is called RXLogit, so it's scalable. And what I'm looking to do is I want to predict default. So I want to say, what's the probability of default? Are they going to pay the debt or not? And in any modeling with R, I use the little tilde character to say what features or variables that are going to go in to predict that you want to use. So we're going to say the debt that they have and years of employment. And our input data set is this more data new that we calculated. Okay. So the idea here is, and you can do any number. Sometimes these features can be 100 and something features, which is mind-boggling. This is why you need programming tools to do it. But based on the debt and years of employment, we're going to try to see, can that be used to predict whether the person will pay the debt or not? So I'm just going to run that through and run it. And one of the things about the logistic model is, it looped around a lot. So that's the cool thing about the logistic model. It actually applies permutations many different times, iterations, trying to calculate the optimal sort of probabilities in the model, and give you the final result says this is the best calculation using that model. So I'm going to get into more about how to use that model for predicting everything, but I wanted to show that. So what we've seen so far, we haven't even gone over to the R server yet. So kind of going through bullet points here. What we've seen so far is using the RX import to load data, using RXGetInfo to get information about the object that holds data. The RXDataStep is a sort of all-in-one ETL tool. RXCube will aggregate data for us efficiently, particularly good on the server side. And some of these special functions, histogram, RX histogram, RX line plot, and RX legit, those are the scale-off functions that will get us to using this model. So finally, now I'm going to get into a little bit more. This is getting more in the real-world scenario, I guess you'd say. These scripts, when you get into the walkthrough, one of the things you have to make sure is you have all the packages you need. So you're going to want to run something like this, and there's a ton of them, different packages you'll need to use all the different things in script. So you just got to get through, install those. I have those installed, so I'm good. The library that holds these scalar functions is scalar. I'm going to just make sure it's installed. And here's the big change. Notice this here. Before we just said local, but now we're going to change it to a SQL Server context. Now, a nice thing I happen to like personally is the way we do that is using good old, essentially a good old ODBC type connection string. So we can see here is the connection string, and we're identifying the server, we're telling it what the ID and password is, what database we want to connect to, so it's just a connection string. This parameter shared dir is just kind of a shared space for writing data out, temporary holding space. That's about it, and I went and browsed it there. There's not really much in there, but it's used by it. SQL wait basically is, I believe, just asking it to wait a certain amount of time to get in. And console output is, because we're running in sort of a remote mode, it doesn't really make sense to write it to the console in the output. So I'm going to run this, and then I'm going to set my compute context. And that's pretty much it. Now I'm in the compute context. Now realize it's not doing a huge amount at that point. You might run into issues if you have any configuration problems, but it's kind of like if you just changed to your, from C drive to X drive, it's not doing a lot. So now I'm going to set up a query that I want to run, and I am going to be running this now in the context of being on the server. And it's selecting top 500 rows, and I want to kind of call your attention to something in here. Let's see. Yeah, okay, so it's just running a query. So I'm going to store it in this variable sample query, and I can kind of prove there's nothing up my sleeve there. So it's just, that's all it is, a variable holding that. And now I'm going to run RX SQL Server data. So the idea here is I'm querying SQL Server. I'm giving it my query. Again, it's probably pretty familiar looking if you've done any kind of ODBC connectors or RODBC or anything. Not much different. The connection string here is what I created earlier. So that's all that is. And here I'm telling it what I want to create is classes. I believe the column classes is just telling it the data types to expect coming back. Okay. And so let's run this. I'll pull in the data from the query. Now it does a kind of lazy loading kind of thing. So it knows the query. It's pointing in the database to the data, but it doesn't actually run it until we force it to. So I'm going to do a summary on it to get it to force it to go against that data and give me some results. I'm sorry, that was actually a bit of a trick. So summary in this case, that's an R function, and all it comes back and tells you that this is an S4 object class. But if I use the getInfo, I can get actual info on the data that's used here. So in this case, it's telling me what columns are in there and what's in the data. And again, this is from the walkthrough, so we'll get some start time. But now we're going to do a summary of the data. So using RX summary right here, we're going to ask it to do this fair amount, basically doing fair amount by passenger count. So it's doing an aggregation, and we'll see what it looks like. It's easier to see than kind of talk about. So there's a lot of data actually going through. It's working fairly well considering. So the idea here is we're doing a summarization of the data that's in the data frame, really an object, and it's pointing back to SQL Server, executing the query, getting the results, and what it should do is give us results based on the passenger count. So what we can see here, what this tells me is that pretty much everybody, all the data has one passenger, but if we had 2, 3, 4, or whatever, we'd get more results back. And that could be the way I've stored the data. I think the results, Microsoft gives you the data set, there's probably more than that, but so that's kind of the idea. So again, the key thing to this is if you were using R's integration with SQL Server and the R server, you got to get familiar with these RX functions and start thinking and using those. If you were converting something somebody else were to give you, I'm actually doing this now, and somebody's giving me something and they've written it one way, I need to convert that into the RX type functions, or at least the R functions in my case, to get it to be to work. So that would be the kind of operationalizer. That would be, we need a new name for that person, but I think Microsoft's name is the data developer. So if you want to be in a hot new spot, I think that's a good career move for people. So here we're going to do our histogram, and we're just using fair amount. This should just get a frequency, just another example. takes a minute. It's one thing when you have a couple of thousand rows, but this actually has quite a bit going on. So, okay, so you get a histogram, and again, so that tells me that the fair amounts are not really a normal distribution, but generally you can see they're kind of clustered anywhere from $30 to about $60 is a fair, so that makes sense. Now this is I'm going to point this out. This is I want to say an error in Microsoft's walkthrough. I hate to not criticize Microsoft, but I could not get this to work, and I tried everything, and it is the exact code that Microsoft had, but it has to do, not completely blaming. There's a lot of pieces sometimes in our analytics environment, and in this case you have to have a lot of libraries in place, and they have to map just correctly, and they sometimes run into namespace conflicts. But the idea behind here is to create a map plot that would show you all the different New York City cab drivers plotted over Manhattan. So to give you some idea of what it would look like, I can use the non-R server-based functions. So this is standard R. And it takes just a little bit. Oh, sorry, not quite done. Oops, no, I'm sorry, I had the wrong code. Sorry, let me run this code, and I can give you a better idea of what we're talking about. Okay, so you can see from this is an R map. Go back a minute. That's an R map, and ideally it would be plotting the different fare locations all over New York City. So that's the idea behind this. So we're looking at New York City cabs, taxis, and the fares. So again, I couldn't get it to work correctly. There seems to be some tweaking needed there, but it's kind of a cool thing had it worked. But I think the main thing is to get the idea that that's what will be going on there. I did find there was a glitch. The code example said Times Square. That doesn't work. You have to use this full path, this full name for it to correctly map Times Square. All right, so getting into now a little more advanced now, we're getting into something with closer to an actual implementation and operationalizing SQL Server. I can never say that word easily. But anyway, the idea here is we're going to use a query again, and this time we're going to call a function which is in the database in our SQL. The idea is to create a new column that's going to be used in predicting the outcome. And to kind of go over here, if I go into programmability here and in my functions, it's a scalar function, I believe, and it's calculate distance. So you can see it there, calculate distance. So I can script it maybe. But just to show you, there's nothing up my sleeve. So the idea here is that it's part of the deployment. When you set up the walkthrough, it creates these functions for you, so you can get an idea of how to do things. And the idea really of this script, of this function, is that you could use an R function or a SQL function to create a new, say, calculated column, which this is doing. So it's calculating the distance between 2 points, basically. And then from that, you could use that in your model as a prediction column, something to predict with. So let me go back here for a minute. Okay. So the query that's pulling data, in addition using that, I'm going to just store that in here. I'm using 10% of the data, so I'm not pulling everything in. I've got a bit of an issue here. Let me see if I can. Okay, I had a little glitch there. I didn't highlight this correctly. Let me try it again. All right. And now what I want to do is I'm going to again use this data set, RX SQL Server Data, which is designed to get data out of SQL Server. And it's not really getting data out of SQL Server, because remember, we are running in the context of the server, which is why it kind of waits until you need it, because it has the reference and we'll use it when it needs it. And we can kind of prove that it does work by just seeing the data types again that come out. And should be able to just display a few rows here. And that just displays a few of the rows. And trying to think but the distance, trip distance here, you can see our calculate column did work. So that's an example of using SQL to do more of the work for you when you can, and not having R do it, which would take considerably longer in that case. And again, like before, we're going to create a logistic model. I'm going to return it to Logit object. So that works. And the system time function just kind of gives you a record of how long something took. And that's built in, that's standard R. Okay, so the main thing looking down below in the console, you can see what it output, and it's giving you a lot of calculations about basically all these things are telling you the relationships it's finding between columns and your desired output calculations. So in here we're trying to find out what's the likelihood that I'll get tipped. I'm the cab driver, I want to know, am I going to get tipped? And to do that, it's going to use the passenger count, the trip distance, which is calculated, the trip time in seconds, the direct distance, excuse me, I think it's the direct distance I calculated, and then the overall data source is this. So that's how it created the model. So a model is going to create relationships and say what's the relationship between your outcome, what you want to know, are you going to get tipped, all these variables. So I've got my model. Now what I want to do is I want to, and typically what you would do, I'm not going to do it here for time reasons, but typically, you notice I took 10% of the data. Typically in creating a model, you would do something like take 70% of the data, put it through the model to create the model, and that would be called your model building data set. And the other one would be one to test the data set afterwards. So now you take the remaining 30%, and you run it through without it knowing the outcome, and then you can compare, well, it predicted I would get tipped, but in reality this is historical, and I know I didn't get tipped. And based on looking at that, you could evaluate how effective the predicted model is. But in this case, we're going to assume we've already done that. And I'm just going to use the same data set through and score it. And to score it, I can use this. I'm going to use a special function, which is this RS SQL Server data. And what I want to do in this case is, after it's done scoring, it's going to write the scores to a SQL Server table, which is called taxi score output. And I can, again, prove over here, taxi score output is right here. So you can see that's where I want to write my results to. So let's run this and this. Now it's going through, it's taking the model that I created, it's reapplying it to data coming in from the source, kind of really reapplying the same thing here, so it's not the best use case in that sense. But had this been a real case, the idea would be you're putting it through and saying, how is it predicting? How effective is it? Is it 90% effective? Is it less? So we've got it now. It's written the scoring out. And now what I'm going to do is I'm going to run it through this function called the ROC curve, which is a very popular way in statistics of scoring models to say how good did it do. So I'll run that. It takes a second. That should come out with a line graph. And the idea is to see that will tell me how effective it is. Okay, and go here. So we can see here, this is called the ROC curve, and it shows that if the ROC curve had been below the line in the middle, the straight line going in the middle, it means it's predicting worse than if we guessed. If it was a flat line going along, just dividing the graph in half, as you can see that white line going through, that would say it's basically a useless model. You can get just as good by guessing. That would be the guess version. So we can see where it bows out. It does have some predictive power, but not a superly powerful model. You'd really want to see a bigger curve so that it leans towards the 1.0 on the upper left. So what this is telling us, and the way you calculate it is actually by the area. You can say how effective it is. The AUC is telling you sort of the effectiveness. You want something that goes towards more like point. Basically, you want something close to 1 is like perfect, and then that kind of thing. Okay. So I'm going to switch gears a bit. So we've done this, and we could continue sort of staying in the context of running everything in SQL Server, but now we're going to sort of think more like a data scientist or somebody who just wants to use standard SQL. And I'm going to use standard ODBC to do some work with what we just created. So I want to take the model we created, I'm going to write it to the database, but I'm going to use regular old ODBC. So I'm going to create these variables, and what I'm doing here is I'm taking the model we have. This is the model, the object model that's got the predictive model, logistic object, and I'm going to store it. I'm going to serialize it, which means it's going to convert it into just a list of data that can write to the database, and then I'm going to paste that into the database later. So I'm going to just grab these two pieces first, and then I'm going to get our ODBC loaded, which allows me to connect to SQL Server through ODBC. And I made a connection through the connection string, and it's the same connection string I used to set context. And here I'm going to write my query and run it. Let's see what we got here. Okay, and what that did is I ran persist model, which is a store procedure in the database. It's no magic as far as this goes. So slow response to my SQL Server, but it's just a store procedure that's out there, so I can see persist model, and that's going to allow me to write the model to the database. And so it actually did write it to the database. That character 0 come back just says, yeah, it wrote it. Now, originally when I did this, I got this really complex query in the walkthrough that Microsoft puts out, and I found out that ODBC does not support that kind of a complex query. So I simplified the query to this, and I'm going to run that instead because it works. And now what I want to do is, my goal is to say, okay, I've got this model. So to kind of review the steps, first I took some data, I created a predicted model, and that model predicts whether or not tips are going to happen. And it's going to give you back a percentage probability, how likely it is to get tipped, as opposed to yes, no. And what I want to do now is I want to do a prediction using that model. So I'm going to use this query as my input. So I'm selecting data out of some source. In this case, it's the same source we kind of created the model out of. And the idea is you now know your probabilities of getting tipped. Now I'm going to look at data sets where I don't know the outcome, and I want to predict how likely is it based on this that I'll get tipped. Now, tipping is kind of immediate, so you don't have a lot of time to sit back and look at that. But a better example might be, I looked at one model that was predicting low birth weights. So maybe you look at historical data and you find out that how to predict based on age and race and where you live and smoking, non-smoking, all these different things. What's the probability that you'll get a low birth weight? And you could put it through a predicted model of patients where, you know, they're patients but they haven't given birth yet, so you don't know. But you could predict the likelihood there'll be a low birth weight, and maybe you take some measures to try to help nurture the baby before it's born and things like that, and help the mother, you know, to make sure it's a successful birth. So there's things like that, or it could be disease rated. But the idea here is I'm creating the query for input, and then I'm going to run that through here. And what I'm seeing here is probabilities returning, so the score is coming back. So it basically took my data, applied the model to it, and so the first piece passed through, it says there's a 51.8% basically chance you get a tip. So again, I'm not really wild about the predictive ability of this particular model because it's just a little above guessing. I'd like to see something more like it's a 95% chance I get a tip or a 0%. But that's the basis of models. There's all different things they can do. Then this one's giving you a percentage. So that one was using a store procedure called predict batch mode, and it passed the query in. And again, there's no magic here. The predict tip batch mode is right there. And if I want to do a single one, I can call the store procedure to call a single predict, essentially. So let's do that. And it gave me 52.4% chance roughly. And notice in this particular case, I'm just hard coding some key values into it, the values that it will use, and then it says, okay, now I'm going to predict off that. So the takeaway really from all this stuff is once you have these things in SQL Server, it's very easy to use the predictive models either in a single manner like we did with the batch, the last one, or the batch mode, we're passing the whole data set through. And since we're calling a store procedure, obviously this could be very easily done through a SQL agent job. So maybe you've got people that are applying for loans, and you've got this great predictive model that will predict whether or not they will default or not. You could then run through new loan applicants through your predictive model through a SQL agent job and output the results into a scored data set, into a scored table, and then provide so somebody could look it over and say, oh, okay, well, this person looks like it's very unlikely they'll pay us back, whereas this person looks like they will. So it can guide you on various types of things like that. Again, the big thing is in R, prior to this kind of integration, you wouldn't be able to do that in a store procedure. It would be difficult to even call R at all from a SQL agent job, and this kind of connectivity would be completely missing. So you can do bits and pieces, but that's a really nice feature. And something I haven't even mentioned at all Not to mention that PowerShell could easily call this model, or anything that could run each SQL server, and Excel could connect to it as well as SSRS, so this is really nice that way. But if you use the rdeploy function, you can even create a web service around your stored procedure and allow external users to use a web service to call it. So you get a lot of flexibility there, and again, it's all in the box. If you own SQL Server, you got it. So that's the big benefit for that. And let me go here for a minute. Okay, so we've covered those features, and this is where I typically go to question and answers. So let me toggle over for a minute. Okay, so yeah, this would be a good time for questions, and I don't see any out there yet, but maybe I'm missing it.
No, I don't see any either right now. But you know, they can email us after the webinar, I'm sure, and I'll make sure you get a copy of it. If anybody has a question and you want to ask, oh wait, here they go. We got a few.
Okay, good.
So are you going to share your scripts? That's a great question.
Yeah, after this, maybe you can send me a place where you want me to store. I'll zip up the file with the presentation and everything. And again, just remember to look for the HTML extension file if you don't have RStudio, and you can, excuse me, do the PowerPoint, and all the scripts will be there too.
Yeah, the next question was everything done in the local content?
I'll explain what I did do, and I hope that answers the question. So the first script I did was working. In my case, it's all on my own machine, so I have SQL Server installed with SQL Server's R server integrated. In spite of that, I'm also able to run as a local client. So my first script that I was demoing was running completely local, not using the R server integration. And the second script I did was demoing the script3_R server walkthrough. That one was actually connecting to the R server and doing the work on the server side.
Let's see. There's a Brad is asking a question about I'm trying to. Can you see the question?
Yeah, I just opened it up.
Let's see.
Is this the one?
It's the very bottom one.
Proc with R code. Is that the one?
Yeah, that's it. Yeah.
Let me see if I can.
Execute a proc with R code is assumed to be as efficient as compute content on the SQL Server here in RStudio.
Well, I think the answer is yes. I think the most efficient way to call a stored procedure would probably be, in SQL Agent or somewhere actually in the SQL context, but probably minimally, because it's just a pass-through. So when you set context, think of it kind of like you change drives as kind of an example. Switch X drive over. Now anything you type in is going to that drive. So there's not a lot of overhead to running things in context. But to the extent that it needs to do a lot of data, I can't get into the internals of how efficient it is if it's using a lot of data between the two. I didn't really get into looking at the R SQL, but the SQL basically has inputs. You basically output in your stored procedure what you want to go to R, and then the R code can work on it, and then you basically point it back through a parameter back to T-SQL to work on it. So it can pass it back and forth, but it is very efficient, and it should be pretty much negligible any differences, I think.
Okay. Can we work with the RX functions when we execute R code from SQL Server?
That's an interesting question. Yes, I believe. I believe the answer is yes if you're writing R code. So if you're writing R code that's within SQL Server context, but it's R code, then you should be able to use those functions. If you're writing T-SQL, then no, because it's not T-SQL. But I'm not aware of any limitations in the scripts that you run that they can't use those things. So yeah, I would say no problem.
Another question is, are all the R functions available in the RX library? And if not, are there any workarounds?
So if you mean R functions, meaning every possible package and library that R has, no. And I'm not sure what workarounds the library would be. That'd be kind of one of those support issues. You get to Microsoft and say, I have this specific, very special model that you guys don't have. So you might not be able to do that. You might be able to kind of create something that works efficiently. yourself and create a model that sort of uses the RX import and writing XDF and things like that to streamline it. But the bottom line is I think the core predictive models that are out there, the basic ones like GLM and things like that, are available and you can use these. And a lot of the standard plotting ones are. I'm not, and you can see how you can use the other models, but when you get into scalability, then you might have some issues if you're trying to use, for instance, you want to use ggplot2, and using 5 billion rows of data you're trying to use with it. That's a ggplot2 limitation, and ggplot2 has not been rewritten as an RX function to my knowledge. So you might run into some of those things. It's going to be, I think, a kind of getting through your modeling and seeing what works. But you can use anything that's available in R. There's nothing to stop you from using ggplot2 or anything else for that matter.
Okay, well, we're kind of out of time now. I want to thank everyone for coming. And thank you, Bryan, for giving it. It was great, personally, from my point of view. I mean, it brought a lot of insight to it, R. And I'd like to have you back later in the year because this is really interesting. I find this stuff great. So
nice.
The webinar is recorded, and if you have any more questions, please email myself. Bryan, do you have an email you could share? Or,
yeah, so my email is on the first slide. I have contact there, but it's just my name with a Y, so it's Bryan, B-R-Y-A-N, 256 at msn.com. So I go way back, MSN. The 256, what it's worth, I chose that because if you fill a byte, that's in the highest number it can hold when you fill a byte up. So I thought that would be easy to remember. So
that's cool. That's really cool. Okay. Thank you, and thanks everyone for coming. And I hope y'all come back next month to see the next webinar. Have a great evening.
Thank you.